Assalamu alaikum everyone. My name is Abu Ansari, and in this video I'll be presenting an introduction to trigonometry, primarily focusing on the radian measure and angles on Cartesian planes. So a brief overview, I'm going to be doing a quick introduction. I'm going to be touching upon radians, special angles, a unit circle, and at the end we'll solve some practice questions. So first off, the introduction. There are a couple of key terms that we must know before we actually get into this topic of grade 12 level trigonometry. So an angle, which is the space between two intersecting lines close to the point where they meet. An oscillation, also known as a revolution, is basically the number of rounds or repetitions of a period in a sinusoidal function. A radian, which is a unit of measurement used in trigonometry, and we'll be elaborating more on that. There's a whole separate section for that afterwards. And a special angle, which are angles that are used frequently due to its corresponding exact values in both degrees and radians. And last but not the least, angular velocity, which is its formula is 2 pi over the oscillations in seconds, or period in seconds. Now, parts of a triangle. This is pretty basic, but it's nice to have a review on this. So the hypotenuse is the side perpendicular to the right angle. And now let's use angle x as our common point here at the bottom right. So now this angle x, now we have opposite to angle x. That's going to be called the opposite side. And adjacent is the side parallel to angle x. Now we use Hakatoa. So sine x is equal to opposite over the hypotenuse, cosine x is equal to adjacent over the hypotenuse, and tangent x is equal to the opposite over adjacent side. Now here is basically something similar of how it would look on a Cartesian plane. So here's a circle, a unit circle we have here. And we have the terminal arms. So the terminal arm is the arm that actually goes right here, right on the x-axis and the positive side. That's the terminal arm. And now what's the green colored angle is what we call the principal angle. And now the red colored angle, that's going to be called the related acute angle, which is beta, usually represented by beta. Now, trig ratios on a Cartesian plane. So, just a quick review. Sine an angle is equal to y over r. Cosine a is equal to x over r. Tangent a is going to be equal to y over x. And in the case that x cannot equal to 0. Otherwise, of course, we'll get undefined. And we can just reverse those values for the inverse trig ratios, so like cosecant, secant, and cotangent. And as we can see here, the formula to find the radius is r equal to root x squared plus y squared. Okay, now moving on to the second point, which is the radian. So what is a radian? It's basically the size of an angle that has a vertex at the center of the circle, as you can see in the image in the bottom right. The arc formed at the edge of the circle is equal in length to the radius. So what's red? A is equal to r. So the length of this curvature on the edge, which is A, is equal to the size or the length of the radius. So as you can see, here's basically a formula of how we deduce what pi is equal to. So theta is equal to A over r, and because they're both technically the same, so it gives us 1. So it has no really unit afterwards. Now, A is equal to 2 pi r, which is also the circumference. And theta is equal to 2 pi r over r. So the r cancels out. And then you have 2 pi that's left. And then we know 2 pi is equal to 360 degrees, because a whole circle has 360 degrees. And then, if you simplify that even further, we get this final answer, which is pi is equal to 180 degrees. Now, radian to degree conversion. So now 1 radian is equal to, we said, 180 degrees over pi. Now, 180 degrees over pi, that's actually about 57.3 degrees. So if you're converting from a radian to a degree, what you would do is multiply it by this common factor, 180 over pi. And if we want to go from degree to radian, because degree is a smaller unit in terms of magnitude compared to radian, all we would do is you would divide it by the same factor. So let's say we have 200 degrees. We would divide it by 180 degrees over pi. And through this process, it basically means it basically equal to 200 degrees times pi over 180. And that's easy to solve, and then you can just simplify at the end. While for converting radians to degrees, as I said earlier, you will simply do, let's say it's 2 radian, you would do 100, you would do basically times 180 degrees over pi. Now the third topic, which is special angles. So here are these two special triangles. We have pi over 4. So basically this is the 45 degrees. Pi over 4 is 45 degrees. And we'll be touching on the unit circle after this, so it'll be easier to do the conversions. So 45 degrees and with 90 degrees, so we know if the legs of the right angle triangle is equal to 1 or x, then we get root 2 as the hypotenuse. And then for the 30, 60, 90 triangle, this is basically 30 degrees, 60, and this is the 90, the right angle. You have the short leg 1, the long leg root 3, and the hypotenuse is equal to 2. Now here is a chart, and it's been color coded to make it easier to understand as well. So these are the special trig ratios in degrees. So as you can see, 0 degrees sine. So I'll go through 0 degrees, 30 degrees, 45 degrees, 60, and 90. But there's something key about from 30 to 60, and mainly between cosine and sine. So if you see, all of them are over 2. All of the exact values are over 2 for sine and cosine. Now what's interesting is, for sine, it's root 1, which is 1, and then root 2, root 3, all of these over 2, and for cosine, it's the other way around. So it's root 3, and then root 2, and then 1 over 2. And then same goes for the 0 and 90 degrees. So sine 0 is 0, sine 90 is 1. Cosine 0 is 1, and cosine 90 is 0. So they both go inverse, exactly the opposite. Tan 0 is 0, tan 30 is 1 over root 3, tan 45 is 1, and tan 60 is root 3. However, tan 90 is not defined because you get 0 in the denominator. Now this is the same chart but in radians. So you have pi. So this is just to have you get a visual understanding, and for you to easily convert between the degrees and the radians. But it's the exact same chart. So 30 degrees is pi over 6, 45 degrees is pi over 4, and 60 degrees is pi over 3, and then 90 degrees is pi over 2. Now, section 4 of this presentation, which is the unit circle. So now the unit circle, I'll just draw a simple diagram to get a good understanding first. Let's draw the axis. Let's draw a circle. I know it's not pretty even, but let's say this is just the unit circle here. So we're going to divide this into quadrants. So this is 1, 2, 3, 4. And also according to the cast rule, which is cosine is positive here, all trig ratios are positive here, sine is positive here, and only tan is positive in the third quadrant. Now, just these four angles, what we'll have to understand is what the ratios are for this as well. So, this is 0 degrees, so 0 radians. And it can also be 360 degrees, which is going to be 2 pi. Now this is 90 degrees, and it is pi over 2. Over here, we have 180 degrees, and we had established earlier that it's equal to pi. And this is 270 degrees, which is equal to 3 over 2 pi. So this is just the simple chart, and in the next slide, I'll be showing you a detailed chart. So as we can see here, this is for all the special angles. So 30, 45, 60, and their related acute angles in all the different quadrants. But there's something key to note here to make you understand. Once you've got the first quadrant down, right? After you understand how the first quadrant really works, then all the other quadrants become easy. So we know that 30 degrees is pi over 6, 45 pi over 4, and 60 pi over 3. Now all we have to do is, in the numerator, make it one less, make the coefficient one less than the denominator. So now 2 pi over 3, that's the 60 degrees related acute angle in the second quadrant. 3 pi over 4, this is the 45 degrees related acute angle. And now 5 pi over 6, this is the 30 degrees related acute angle in the second quadrant. Now, so I'll add that as a note over here. Numerator is one less than the denominator. Now, in the third quadrant, the numerator is one more than the coefficient. In the numerator is one more than the denominator. So you can see 7 pi over 6, 5 pi over, so it's one more. Okay, and now in the final one, this you can memorize, or you can also find another correlation. So comparing this to the third quadrant, so if we're looking at the fourth quadrant right now, comparing this to the third quadrant, you need to match. So okay, 4 pi over 3 is the 60 degrees related acute angle in the third quadrant, but in the fourth quadrant it's 5 pi over 3, so it's 2 more. Now times the difference, which is 2. Okay, so sorry, it's 1 more, right? 4 and 5. 5 minus 4 is 1. So now that's 1. There's a difference of 1. Now you times it by 2, and there'll be a difference in 2. So times 2, and you can just add it right here. So 5 plus 2, and you get 7. 7 pi over 4. Now to get here, you have to multiply the difference by 2. So we multiplied to get to here, we multiplied by 2, right? And added the value that we got. So now we had 2 over here. Now multiply that by 2, we get 4. So now 7 plus 4 is 11. And you get 11 pi over 6. Now, this is the last part. So solve a couple questions based on the content that we had discussed. So convert degrees to radians in exact form. Now, I'll do a follow through for the first one, and then we can quickly go on to and answer the next couple of questions. So for basically what we will do is converting degrees to radians, as I said earlier. So 75 divided by 180 over pi, which is the same as 75 times pi over 180. Now all you have to do is simplify, because they say exact form. So then we get, so if we divide by 5, we get 36 pi. We get 36 pi over, let me just calculate this real quick. Yeah, we got 30, sorry. So 75 divided by 5 will give us 15. So 15 over 36 pi. That was a mistake there. So 15 pi over 36. And now we can simplify that even further to make it 5 pi over 12. And that's how we basically solve it. Now we will just do the exact same for 280. I hope we can get right into it. So 280 pi over 180. And then you'll just simplify it and you'll do the exact same for the next two questions. Now converting radians to degrees. Here again, one easy thing that you can do is just substitute the pi with 180. So we do 5 times 180 over 3. Then you will get the answer 5 times 180. And that gives us 900. Divide that by 3. We get 300 equal to 300 degrees. 0.7 times 180. And we get 126. 0.7 180 equals 126 degrees. 13 times 180 divided by 6. 390 degrees. And now pi over 4, which is simply 180 divided by 4. And that will give us 45 degrees, which we had established is a special angle. Now moving on to this question. This is an application question, so it's a little tricky here. We have to solve for x and for theta. Now, we know that, okay, so it'll be easier to solve theta first because we have these two sides over here. So we can get this bottom angle down here. So now we know this is adjacent, or we can also say it's opposite over adjacent. No, opposite over hypotenuse, because we can see this is the right angle. So it's opposite over hypotenuse, and that is sine. So basically, sine theta is equal to 4 over 8. Now we can do inverse sine. So theta is going to equal to pi over 6. And degrees is 30 degrees. And we know this is a 90-degree angle. And we know, or as pi over 2. And we know that all triangles, if you add up their angles, it will give us 180 degrees, which is pi. So pi over 6, right? Pi over 6 plus pi over 2, which is 90. And if you add that, we end up getting pi over 3, which is 60 degrees. So we know now that this is pi over 3. And because these two lines intersect, they create corresponding angles. That means that this whole thing is going to be pi over 3 as well. And it's supposed to be given here. Maybe I forgot to add on the slide, but this angle, it's by itself is pi over 12. This by itself is pi over 12. So now all we have to do is just do pi over 3 and subtract that by pi over 12 so we can get what this angle is by itself. what angle ECF is, which is just this angle. So to get that, we're going to have to do pi 3 minus pi 12. Now we need to get the common factor, so this multiplied by 4, that gives us 12, and this multiplied by 4. The 4 minus pi, that gives us 3 pi and over 12. And we can simplify this further to give us pi over 4. And we know pi over 4 is 45 degrees. So this is 45 degrees over here. Right? Now, we know that one angle, which is ECF, so angle ECF is equal to 45 degrees, and we want to find X, and we also know what CE is. So CE, side CE, says is 4.5 centimeters. So we also have that as a given. Now, all we have to do is find a ratio and use one of the trig ratios to give us the value of X. So if we analyze here, 45 degrees is angle ECF, and we have the angle adjacent to it. So in this case, and X is the hypotenuse. So in this case, we'll have to use cosine, because cosine, as we learned, is Hakatoa. Cosine is equal to adjacent over hypotenuse. So cosine pi over 4 is equal to adjacent, so 4.5 over hypotenuse. Now to solve this, we basically bring 4.5 to the other side, and that means that 4.5 over cosine pi over 4 is equal to X. Hence, X will be equal to, so let's calculate this. We get 6.36 approximately, so 6.36 centimeters. And that is our final answer for X. And we had solved theta over here. Now this is our last question, which has to do with the trig exact values. So we know sine is, okay, so we know the different sine trig values that I had shown in the table earlier. So sine, we know that its exact value is, okay, so let me give you some tips on how to actually tackle the problem first. You have to look at the denominator when the fraction is fully factored. So if the denominator is 3, that means we're talking about the 60 degrees. Okay, and we know that 60 degrees for sine is square root 1 over 2. Basically 1 over 2. So that's for, sorry. Yeah, so for the 60 degrees, it's actually square root 3 over 2. So now that we know that it's 3 over 2, we have to figure out if it's in the first, second, or third quadrant, right? So we know this is in the second quadrant because the numerator is 1 less than the coefficient in the numerator is 1 less than the denominator. And according to the cast rule, if I just put it as a visual here, it is positive. So this is the answer. Now for this one, tan 11 pi over 6. Now we're talking about the 30 degrees because pi over 6 we know is 30 degrees. And for 30 degrees we know that tan is 1 over root 3. Now we have to figure out where is this in which quadrant this is. And this is in the fourth quadrant, and tangent is not positive there, so this will be the answer. It'll be in negative 1 over root 3. Now we'll just do the same thing for question 3 and 4. We know the numerator is 1 more than the denominator. That means it's going to be in the third quadrant. So, and cosine is not positive there. And we're talking about the 45 degrees. So, it's going to be equal to negative square root 2 over 2. Now, last but not the least, cosecant. Now, cosecant is the inverse of sine. Now, we'll treat the trigonometric ratio as it is. So, we know we're talking about the 60 degrees. The 30 degrees because it's pi over 6. So now, we know pi over 6 for sine is so pi over 6, which is 30 degrees for sine, is square root 1 over 2, right? And we know that this is actually in the second quadrant, so sine is positive here, so we don't have to add the negative sign. But because it's cosecant, we'll have to switch it around, so that's 2 over square root 1, and to rationalize the fraction, because you can't have a radical in the denominator, all we will do is multiply this by square root 1, which doesn't do anything, so it's just 2 basically. So the answer is 2. And that's all for this presentation. Jazakallah khair for watching. If you have any questions or comments, feel free to ask them in the comments below. Jazakallah khair.